Hello, this video is on section 3.2, which is properties of parallel lines. And there's two targets today. The first one is to use theorems about parallel lines, and the second one is to use properties of parallel lines and find angle measures. They're both equally important, kind of saying the same thing, but using them differently. Two is an application of the first target. Whatever one you want to fill out on your learning target sheet is totally up to you. But let's go ahead and get started on the four theorems. So these are still the same ones that are in the last video, where we have same side interior angles, alternate interior corresponding, and alternate exterior, except this time there's some special cases that happen when those two lines are parallel. So if we go back to our diagram and we have two lines that are parallel to each other, L is parallel to M, there's specific things that happen within each of these angles. And depending on where the transversal is and each of the angles you're looking at depends on what's happening. So the first one I want to talk about is same side interior angles. And the same side interior angles are exactly like the last video, where they are both on the same side of the parallel lines, or they're inside the parallel lines and they're on the same side of the transversal. So that means if a transversal intersects two parallel lines, then these same side interior angles are supplementary. They are not congruent. I do not know why I wrote that. Supplementary. So that means they add up to equal 180 degrees. Now, alternate interior angles is that if a transversal intersects the two parallel lines, and the alternate interior angles are congruent. Now, these ones are congruent, and that's, remember, alternate is opposite sides of the transversal. One is on the left, one is on the right. And interior is they are both on the inside of the parallel lines. And that means that they are congruent. Corresponding, if you have two parallel lines with the transversal intersecting them, then that means the corresponding angles are congruent. This symbol stands for congruent, by the way. Same thing with this one right here. Okay, then alternate exterior angles. If the two lines are parallel and you got a line intersecting at the transversal, then the alternate exterior angles are congruent. Okay, so let's look back at another diagram where we do have two parallel lines right here and a line cutting them, intersecting them both, a transversal. The same side interior angles are 3 and 5. They're both on the left of the transversal and they're on the inside of the parallel lines. So that means that the same side interior angles, 3 plus 5, is equal to 180 degrees. They are supplementary. The exact same phenomenon happens with angles 4 and 6. They're on same side interior, so they add up to 180 degrees. Alternate interior angles, if these two lines are parallel, alternate interior are 3 and 6. They're on opposite sides of the transversal and they're inside the parallel lines. That means that they are congruent. So angle 3 is equal to angle 6. If this was, say, 125, then angle 6 would be equal to the exact same number of 125. The same exact thing happens with angles 4 and 5 as alternate interiors. They are equal. Corresponding, each of the four pairs of corresponding angles, 1 and 5, 2 and 6, 3 and 7, 4 and 8, are congruent to each other. This is if and only if the two lines are parallel. Then alternate exterior is exactly like the other ones where they're congruent. 1 and 8 are alternate sides of the transversal and they are on the outside, so that means that they are congruent. 2 and 7 are both on opposite sides of the transversal, outside the parallel lines, and they are congruent. So this is exactly like the theorems that we introduced in the last video, except this time we're talking about what happens if the two lines are parallel. Okay, thank you.